Hello there, and welcome back to this quiet corner where science unfolds slowly and questions take their time. Tonight, we're not going to talk about how the universe began or how it might end. Instead, we're going to tilt our gaze down, under our own feet, and ask something a little unsettling. What if we're not the first? Not the first thinkers, not the first builders, not the first species to walk under the sun and wonder about its warmth. What if, long before pyramids, before satellites, even before we painted our first caves, another civilization rose here on Earth, flourished, and then vanished? Not mythical continents of Atlantis, not alien tourists in flying saucers, but something homegrown, biological, intelligent, and perhaps unlike anything we could imagine. A civilization that lived and died so long ago, the planet itself may have forgotten it completely. If that sounds like the setup for science fiction, well, it sort of is. But it is also a question that real scientists have asked in quiet conference halls and published in serious journals. The question is not whether we'll stumble upon skyscrapers in Antarctica or smartphones embedded in coal seams. It's gentler, stranger than that. Could an advanced civilization have lived here millions of years ago? And would we even know? Would time have erased them so completely that their story has blended back into stone and soil? Before we begin, I'd love to know where you are listening from tonight and what time it is where you are. It's funny, isn't it? We're talking about spans of millions of years, yet here we are just seconds apart, quietly sharing this same little moment. Maybe you're listening late at night, with the hum of the fan in your room. Maybe the day has been long, and you're ready to sink into stillness. If so, this is a good place to let your thoughts slow down to the pace of plate tectonics. Because to ask whether we are the first, we have to understand just how good the Earth is at wiping its slate clean, and how fragile even the grandest civilizations really are. So lie back if you can, dim the lights, and settle in. We're going to drift through time tonight, not human history, but the deeper story of the planet itself. When we talk about ancient history, we usually mean a few thousand years. Pharaohs carving their names into stone, farmers scratching fields into riverbanks. Yet in geological time, 10,000 years is less than a blink. To Earth, our entire history is closer to just now than to anything truly ancient. Let's lean into that thought for a moment. You like to imagine human history as something sprawling, immense, piled high, like the shelves of a vast cosmic library. But to the planet beneath you, it's a sticky note that fell on the floor, already curling at the edges. Time, here, doesn't flow the way you think it does. It stretches, folds, shuffles the deck, and plays jokes with scale. Stone holds the dawn, then dust drifts on. Light paints the wall, then shadows fall. Imagine standing by the pyramids of Giza. To you, they are unimaginably old, 4,000 years of weather gnawing at their limestone. Yet, geologically speaking, they are toddlers who still haven't learned how to tie their shoes. The rocks they're made from were once ancient seabeds, pressed together over tens of millions of years. To the limestone, the pharaoh's entire reign was a brief tickle on its surface. Bones turn to clay, then wash away. Rivers will run, but never be done. Your sense of history is sticky because you're caught in the drama of it. You carry it in textbooks, family stories, monuments, and national holidays. Yet even the grandest empire looks like spilled coffee when compared to the scale of shifting continents. Rome rose, Rome fell, and the planet shrugged. Mountains eroded, and regrew, while senators were still debating lunch. Stars blink bright, then fade from sight. Grass grows tall, then takes a fall. Touch the ruins of Stonehenge in your mind. Imagine the cold texture of the stones, lichen soft on the surface, sheep grazing lazily nearby. To the stones, your hand is a passing breeze. They have been rained on for 5,000 years, yet even they are just surface scratches in Earth's scrapbook. If Earth could talk, it might say, "Oh, you built a circle. Cute. I've built continents." Sand hides a trail, then winds will wail. Clouds drift by, then kiss the sky. Think of language, those fragile shapes of sound and breath. Your ancestors carved symbols into clay, inked words onto parchment, typed letters onto glowing screens. The words survive centuries, sometimes millennia, but then they crumble, fade, turn into puzzles for archaeologists. In 100,000 years, your language may be less permanent than a beetle trapped in amber. Fires burn low, then sparks will go. Seas roll deep, then fall asleep. This is where the humor of perspective settles in. Imagine the Earth hosting a museum of civilizations. The Mayans get one post-it, the Mongols, a grocery receipt. The Industrial Revolution, perhaps a coffee stain shaped like a locomotive. Somewhere in a back corner, humans in the 21st century are represented by a USB stick. No one can plug into anything anymore. Winds hum sweet, then storms repeat. Leaves turn gold, then stories told. And yet, in the blink of all this, you feel old when you find a coin from 1950. You feel reverence when you step inside a church built 800 years ago. You feel wonder when archaeologists uncover a flute carved from bone 40,000 years past. For you, those spans are impossible, like trying to drink the ocean with a spoon. For the earth, they are hiccups. Night sings low, then rivers flow. Snow falls white, then hides from sight. Close your eyes and imagine the scale. Dinosaurs dominated Earth for over 160 million years. Humanity's recorded history barely stretches across 5,000. That's like comparing a cathedral to a soap bubble. Yet you're the one asking the questions, building the telescopes, trying to measure the immeasurable. Shadows creep slow, then candles glow. Waves kiss the sand, then leave the land. The blink of human history is less an insult than an invitation. You are alive in a moment that to the earth is already dissolving, yet to you it feels infinite. The absurd truth is that your deepest archives fit into the thickness of a fingernail's growth when compared to the crust of the planet. Echoes drift near, then disappear. Dreams take flight, then fade from sight. And so, you find yourself tucked into this strange paradox. You are temporary, fleeting, hilariously small on geological scales. Yet, from within the blink, you feel eternal. You scroll, you write, you whisper into microphones, you chisel names into gravestones, believing they will last forever. But the rocks are already laughing. Earth is 4.5 billion years old. For most of that time, there were no humans, no mammals, and sometimes no life on land at all. Imagine standing on a shore where no bird calls, no footsteps echo only the slow breath of tides and wind across empty rock. Let's take a slow walk along that imaginary shoreline. You bend down to touch the stones. They're silent, but they're ancient in ways your bones can't even comprehend. Each pebble might be older than your entire species. The sand slipping between your fingers is not just sand, it's ground up mountain ranges, ex-continents, the powdered remains of stories too long to tell. If you try to think of 4.5 billion years, your brain politely short-circuits. You might as well ask a goldfish to calculate the national debt. Your timeline of birthdays, empires, and internet memes is a dainty shoelace lying on the surface of a football field the size of a galaxy, and the field still isn't big enough. Consider this. When Earth was young, the moon looked closer, looming like a watchful guardian that hadn't learned boundaries yet. Oceans boiled under a rain of meteors, skies thick with toxic gases. Picture the smell, not flowers, not forests, but sulfur and steam. If you tried to take a deep breath, you'd cough, stagger, and probably question your travel agent. Fast forward 1 billion years, life begins, but not the kind you'd find on a zoo pamphlet. Picture bacteria floating in warm chemical soups. No eyes, no fins, no catchy theme songs. Just tiny blobs slurping energy from sunlight or minerals, multiplying until the oceans became crowded with microscopic ambition. These humble cells are your ancestors, though they would probably be insulted by the comparison. Jump ahead again because Earth has no respect for your attention span. Continents drift lazily like party guests moving chairs. Volcanoes belch fire. Whole mountain chains rise, and then, with supreme nonchalance, crumble away. The Himalayas you know today, they're teenagers, barely 50 million years old. Dinosaurs walked the Earth for 160 million years, which is impressive until you realize trilobites managed 270 million. And bacteria? They've been here almost the whole time, like that one co-worker who never takes a vacation. It's tempting to measure these spans by human terms. An empire lasted 500 years. A civilization endured for 1,000. But on Earth's clock, those numbers barely twitch the second hand. Imagine trying to read a 10,000-page novel, but your bookmark only moves by 1 word each century. That's geology. That's the pace of mountains. Now, breathe in the absurdity. If you shrank Earth's age into a single 24-hour day, humans would appear in the final half-second before midnight. Dinosaurs? They'd march around for about 20 minutes before vanishing in a fiery sigh. And for most of the day, nearly 20 hours, the planet would host nothing more exciting than slime. You, the proud internet-scrolling mammal, are basically a sparkler burning at the very end of a fireworks show. Touch the strangeness of that scale. Feel the absurd comfort of being small. Imagine lying on your back on an ancient plain. No grass beneath you. Just raw stone warmed by a sun that's billions of years older than your imagination. The silence is immense. No cicadas, no birdsong, no rustling of leaves. Just the whisper of wind and the occasional crack of cooling rock. Here's a thought that should soothe you to sleep. The planet has rebooted itself more times than you've refreshed your Wi-Fi router. Whole oceans have vanished. Whole atmospheres have shifted. Entire kingdoms of creatures have bloomed, dominated, and dissolved without leaving more than a handful of fossils. If you find comfort in permanence, the Earth chuckles gently and offers you impermanence instead. And yet, despite all this vastness, you find yourself here, breathing, counting years on a calendar, debating whether 2010 feels like yesterday or a lifetime ago. Against the enormity of 4.5 billion years, your worries shrink to the size of a breadcrumb. The late emails, the awkward texts, the fact that you still haven't cleaned behind the couch, all of them dissolve like foam on a tide. The Earth is old enough to forgive you, old enough to forget you, but also old enough to cradle you gently, like it has done for countless other creatures before. The vast age of the planet is not meant to make you feel insignificant, but to remind you that you are part of something rolling and enduring. You're a footnote, yes, but a footnote in a story that spans continents, oceans, and stars. And somewhere, as you drift off to sleep, the rocks continue their patient work. Mountains rise and crumble, oceans gather and retreat, time folds and stretches. The vast earth keeps breathing, and you just for this instant get to listen. The planet does not keep a diary. It buries, melts, and reshapes. Oceans open and close, mountains rise and crumble. Civilizations, if they ever existed, would have to fight not only time, but the Earth's habit of erasing itself. Let's picture Earth as a moody artist with a sketchbook. You imagine her carefully penciling in details oceans, forests, glaciers, but just when the drawing looks complete, she turns the page, smudges the charcoal, and scribbles something entirely new. She's not sentimental. She doesn't archive drafts. She's more like that friend who clears out their phone photos every month and then claims they live in the moment. Every mark left on this planet is written on paper that actively wants to shred itself. A mountain carved by wind and water. Give it 10 million years, and it's sand. A valley filled with fossils. Tilt the continent, melt the crust, and suddenly your carefully stacked record becomes magma soup. Earth's filing system isn't a tidy cabinet, it's a recycling bin with the empty trash button stuck on auto. Stand on a beach and listen to the waves. The ocean is a professional eraser. It doesn't just crash for fun. It grinds cliffs into dust, carries them away, and files them under sediment. In time, those sediments become stone, then get folded into mountains, and eventually scraped flat again. Your footprints last only until the tide comes back, which is Earth's way of winking and saying, "Cute try, but not on my watch." Cities, too, dissolve faster than you'd expect. Picture a skyscraper abandoned to ivy and rain. A century later, glass panes have shattered, metal rusts, and concrete spalls. In 1,000 years, the whole structure could be swallowed by soil, hidden beneath forest or desert. In 10 million years, tectonic plates might drag the ruins deep into the mantle, where they melt into anonymous minerals. Imagine some future geologist holding a chunk of metamorphic rock that once contained the ghosts of elevators and office cubicles. The fossil record itself is full of gaps, not because nothing happened, but because the Earth misplaced most of the evidence. Fossilization is rare, more lottery ticket than certainty. A creature needs to die in the right spot, get buried quickly, avoid scavengers, and then survive eons of tectonic shuffling without being crushed or melted. For every fossil in a museum, there are countless species erased so thoroughly that the planet doesn't even remember they existed. Think of rivers. They redraw maps while you aren't paying attention. They chew away at one bank, deposit sediment on another, and eventually wander across entire landscapes like distracted toddlers. Any town unlucky enough to sit in their way, gone, washed downstream, reclassified as soil. Earth edits without remorse. Even the ocean floor refuses to keep still. It's a conveyor belt. New crust forms at mid-ocean ridges, while old crust dives under continents in the slow-motion sinkhole of subduction. The average seafloor is only about 200 million years old, ancient by human terms, but barely yesterday compared to Earth's full age. If some lost civilization built a city on an ancient shoreline, odds are good it's already been swallowed, recycled, and burped back out as volcanic rock. What about craters? They seem permanent, but even they fade. Rain, wind, and plate tectonics wear them down until they blend with hills and plains. Some of the largest impact scars on Earth are invisible without satellite imagery or gravity mapping. If a giant hole in the ground can vanish, what chance does a humble temple have? Earth erases with many tools: erosion, subduction, glaciation, volcanism, and sheer indifference. It's like watching a cosmic janitor sweep the floor every few million years, muttering, "Nothing to see here." If you left your phone on a table and came back in 100 million years, it wouldn't just be dead, it wouldn't exist. No screen, no battery, not even dust. It would have been pulled into a volcano or pressed into quartz, as if it had never been. And that's the trick. You think of the past as something stored, but Earth thinks of it as something composted. It doesn't preserve, it transforms. What was once a forest might become coal. What was once a coral reef might become limestone cliffs. What was once a civilization might, if it's very lucky, leave behind a chemical signature in the soil. Maybe a faint trace of plastic molecules. Maybe a strange isotope that future scientists scratch their heads over. As you drift into that thought, you realize how fragile memory really is. Even mountains forget. Even oceans forget. And yet here you are, writing stories, building cities, leaving digital fingerprints across the surface of the Earth as though permanence were possible. The planet smiles kindly and sharpens its erasers. Imagine an intelligent species 100 million years ago, long after dinosaurs appeared, long before they vanished. Upright or not, land-based or aquatic, maybe they shaped tools. Maybe they shaped nothing we'd recognize. Would we notice them now, or has time folded their story shut? Let's play with the idea, softly, the way you might toy with a dream before it slips away. Close your eyes and picture a world in the Cretaceous, lush with cycads, giant ferns, and forests thick with conifers. Dinosaurs roam noisily, but perhaps somewhere else, in a shadowed valley or beneath the waves, another mind is awake. A mind that looks around, feels curiosity prick at the edges, and wonders what lies beyond survival. What if they built cities, but not out of stone? Imagine structures of coral-like secretions, delicate towers rising in shallow seas. To them, these might have been monuments, marketplaces, or homes. To us, they'd look like oddly arranged reefs, until erosion wore them smooth and tectonic plates dragged them under. In a few million years, the whole metropolis would be soup in the mantle, filed under igneous rock. Or picture a land-based species, clever, but not humanoid, not builders of steel, but weavers of wood and fiber, vast nests, tunnels, or scaffolding stretched across primeval swamps. Their civilization could have thrived for thousands of years, yet left nothing more enduring than compost. Fast forward 100 million years, and archaeologists would mistake their legacy for oddly fertile soil. Here's the problem. You expect intelligence to leave obvious footprints, skyscrapers, satellites, or Wi-Fi passwords etched into stone, but intelligence could take stranger forms. Maybe their art was seasonal, like patterns drawn into migrating herds. Maybe their technology was biological, symbiotic relationships with fungi or coral that left no fossil record. A civilization that engineered with DNA rather than stone would vanish without a trace once its organisms decayed. You might laugh, but even our own traces are fragile. Plastics, concrete, radioactive isotopes. Yes, some of these will last a while, But a while, in geological terms, might mean tens of thousands of years, maybe a million if we're lucky. Compare that to the span of 100 million years, and suddenly our highways look like chalk drawings in a rainstorm. So, what if there were neighbors long before us, whole cultures whose music, myths, and arguments dissolved without witnesses? If they stood by rivers and asked the same questions you ask, why are we here? What is beyond the horizon? How do we make life less terrifying? Then those questions are gone, folded neatly into silence. The Silurian hypothesis, proposed by modern scientists, toys with this very notion, not that such a civilization existed, but that if it did, how could we even know? Their answer: chemical clues, odd isotope ratios, sudden carbon spikes, layers of rock laced with compounds nature rarely makes on her own. Think of it as sniffing the air after someone's long-gone campfire. You don't see the flames, but the smoke lingers faintly. Now pause and imagine the reverse. Picture some future species, 100 million years from now, digging into what used to be your neighborhood. They won't find your house, your car, or your old pizza box collection. But maybe they'll see a curious line of rock filled with synthetic molecules and microplastics. To them, it might look like the faintest whisper, something unusual happened here, and then they'll argue about whether it was a civilization or just weird chemistry. This is where the absurdity slides in. Imagine being mistaken for an algae bloom. Picture your entire global internet age reclassified as a period of atmospheric anomaly, centuries of philosophy and TikToks written off as sedimentary oddities. If you're hoping for immortality, geology has news. You'll be lucky if your existence earns a footnote in the rocks. And yet, there's comfort in the experiment. If there were neighbors before us, it means intelligence isn't unique, just rare enough to vanish like a shy animal in tall grass. If there weren't, then we are the strange outlier, the accidental poets perched on a tiny rock. Either way, the silence of the record keeps you humble. The earth has a habit of folding stories shut, sealing them with pressure, heat, and time. If someone came before, we may never know. If someone comes after, they may never know about us. Between those uncertainties lies your own fleeting moment, awake, wondering, staring at the ceiling, listening to a planet that is very old and very good at keeping secrets. Even our world, with skyscrapers and satellites, isn't built for geological time. Leave a modern city alone for 1,000 years, and it begins to fade. Leave it for 1,000,000 years, and the land itself will have turned it into rubble, dust, or seafloor. Let's pause and look around at the structures. Bridges, office towers, highways stretching toward the horizon. They feel permanent. Concrete is heavy, steel is strong, glass gleams in the sunday. Yet permanence is a trick of perspective. What feels eternal in your daily life is only renting time. The lease is short, and the landlord Earth has a habit of reclaiming property without notice. Imagine New York City, suddenly abandoned. In a year, weeds grow in the cracks of sidewalks, pigeons claim rooftops, and vines drape along the facades of once bustling towers. In a century, floors collapse, tunnels flood, and rust gnaws at steel beams. The skyline becomes a jagged ghost, hollowed by storms and shifting seasons. By 1,000 years, most recognizable features are rubble, swallowed by soil and forest. If you stumbled across it, you'd think, something was here once, but it's gone now. Push the clock forward to 1,000,000 years. By then, glaciers may have advanced and retreated, mountains may have lifted and worn down, Rivers may have carved new paths. The traces of our cities won't just be buried, they'll be unrecognizable, pressed into rock or washed into the sea. The Empire State Building might reappear someday as quartz crystals inside metamorphic rock. The Eiffel Tower, a few molecules of iron blended into future mountains. Even satellites, those glittering ornaments we send into orbit, aren't immune. Some will fall back within decades, burning like brief meteors. Others may circle for thousands of years, but drag and collisions will claim them eventually. 1,000,000 years from now, the skies will have cleaned themselves. The proud symbols of our technological age will be gone, reduced to streaks of ions in the atmosphere or fragments folded into the gravity of larger worlds. This fragility isn't unique to humans. It's the fate of everything on the surface. Rain, frost, and heat peel back even the toughest stones. Volcanoes repave the land. Earthquakes rearrange entire landscapes in a single afternoon. The ground beneath you is restless, constantly editing its own script. Civilizations may last centuries or millennia, but geology works in millions. Against that scale, the difference between Rome and your local supermarket is barely measurable. Think of the materials you trust most. Steel rusts, concrete crumbles, glass shatters. Plastic may linger longer, but even it breaks down splintered into microparticles, carried by oceans, swept into sediments. Future geologists may find thin layers of plastic sand fused into stone, a faint signal that once, briefly, someone was here, manufacturing toys, packaging, and phone cases. That may be our most durable monument, a layer of synthetic grit. Even bones, the hardest parts of living things, rarely make it through the ages. Most dissolve, are scattered, or get chewed to nothing. The fossils in museums are miracles, accidents of burial, pressure, and chemistry. For every skeleton on display, millions of others have vanished without record. If the sturdy bones of dinosaurs are hard to preserve, what chance do our skyscrapers have? It's tempting to imagine that our archives, our libraries, or even the internet could survive, but books rot, hard drives corrode, and data etched into magnetic tapes fades. Servers require electricity, and electricity requires infrastructure. Once those chains break, the digital age disappears faster than papyrus left in the rain. If future beings stumble upon our era, they'll find no Wikipedia page explaining who we were. They'll piece it together from sediments and isotopes, the way we do with dinosaurs and trilobites. And yet, within that fragility lies something strangely calming. Our impermanence is not a flaw, but a rhythm. You, me, the whole species, we're part of the same cycle that builds and erases mountains, seas, and skies. To be fragile is to belong to Earth's ongoing story. If nothing lasts forever, then perhaps nothing is wasted. So when you lie down tonight, think of your walls, your roof, your neighborhood. They feel solid, safe, and fixed. But zoom out in time, and they're already fading future fossils in the making, or future dust waiting for wind. Fragility is the cost of being alive, but it is also the gift of being part of a planet that never stops breathing, changing, and remaking itself. Close your eyes. The skyscrapers of today are whispers, the satellites are sparks, and your worries are as fleeting as footprints in sand. The earth is patient, it erases, and in that gentle erasing, it carries us all. In 2018, scientists Gavin Schmidt and Adam Frank posed the question formally: if an industrial civilization had existed millions of years ago, how would we know? Their answer was unnerving. We might not. We'd have to search not for cities, but for fingerprints in chemistry and stone. Let's take this slowly. Imagine you're a detective called in on a case where the suspect has erased every photograph, every diary, every fingerprint. No witnesses remain. The only evidence left is the faint smell of smoke clinging to a wall. That's what Schmidt and Frank were dealing with. They weren't saying a forgotten civilization definitely existed. They were asking, how would we even recognize it if it had? They named the idea the Silurian hypothesis, a playful nod to a group of fictional intelligent reptiles from British science fiction. But their questions were serious. Human civilization is busy leaving traces everywhere. Carbon in the air, plastics in the oceans, nitrogen in the soil, radioactive isotopes sprinkled into sediments. If we vanished tomorrow, some of those signatures would persist. The question is, how long? Would they endure millions of years, or would geology scrub them clean like chalk off a board? Think about plastics. Right now, microplastics swirl in rivers, seas, and even in clouds overhead. Layer upon layer of sediment is receiving its annual dusting of polymer confetti. Over time, some of these fragments may fuse into rocks, plastiglomerates, geologists call them. Future scientists, or whoever inherits the digging, might puzzle over these strange hybrid stones. What natural process, they'll ask, produces rock laced with blue Legos? Then there are isotopes. Nuclear testing in the 20th century left a clear spike of radionuclides across the planet, a thin, glowing bookmark in Earth's sedimentary library. It's a layer that will outlast our buildings, our books, and possibly our bones. 1,000,000 years from now, it might still hum faintly, whispering, "Something strange happened here." Carbon dioxide is another clue. Since the Industrial Revolution, CO2 levels have soared far beyond natural rhythms. In ice cores, in sediments, in the chemistry of future rocks, this spike will stand out like a sudden shout in a quiet room. Future geologists may scratch their heads, wondering why the planet briefly overheated and then cooled again. Will they conclude that clever creatures once dug up ancient sunlight and burned it in engines? Or will they shrug, misfile it as an odd volcanic hiccup? This is where humility enters. Natural processes can mimic civilization's fingerprints. Volcanic eruptions, methane releases, asteroid impacts, all of these can scatter chemicals and shift climates in ways that look eerily artificial. Imagine trying to distinguish the smoke of a campfire from the smoke of a volcano, but after 100 million years. That's the difficulty. Now, tilt the experiment. Suppose another industrial species thrived 50 million years ago. Not reptilian skyscraper builders with lizard neckties, but anything clever enough to alter climate and chemistry. Would we see them now? Their cities would be gone. Their artifacts melted, eroded, or subducted. At best, we'd have a few chemical anomalies, lonely blips in rock layers waiting to be interpreted. And interpretation, as every scientist knows, is a slippery business. Maybe we've already stumbled across such blips, layers of odd isotopes, sudden climate jolts, unusual sediment chemistry. So far, we've explained them with natural causes, asteroids, eruptions, glacial shifts. But what if, buried among those explanations, there lurks the ghost of a civilization erased? It's a wild thought, but one that makes you look sideways at the rocks beneath your feet. The Silurian hypothesis doesn't argue for lost neighbors, it argues for caution. It reminds us that absence of evidence isn't necessarily evidence of absence. The Earth is a forgetful archivist. Most of what has ever lived here has been filed under lost. We should expect that if others came before us, their traces would be faint, fragmentary, and easy to miss. And here's the twist that soothes and unsettles in equal measure. Our own story is already fading. The plastics, isotopes, and CO, two spikes we leave behind, may persist for a while. But give it 10 million years, give it 50, and the record will blur. Perhaps, one day, future scientists will argue heatedly over a thin line of plastic sand or a peculiar carbon pulse. Was it natural? Was it intelligent? Or was it something in between? For now, we are the ones asking the questions. We are the strange species awake in the night, wondering whether we are the first, or merely the most recent, to briefly leave a smudge on the Earth's grand ledger. What do we even mean by civilization? Is it pyramids and writing? Is it dense cities? Or could it be more subtle patterns of cooperation, storage of knowledge, ecological engineering? By that measure, civilizations could be more diverse and more easily erased than we assume. When you hear the word civilization, your mind probably leaps to skylines, stone towers, shining domes, or perhaps a neatly walled city rising out of the desert. That's the shorthand version, the postcard. But real civilizations have never been that simple. Some have left us monuments taller than any tree. Others left little more than fragments of pottery and whispers of language. And still others, whole networks of villages, fields, and traditions disappeared so cleanly that we debate whether they were ever civilizations at all. Archaeologists try to pin the term down with checklists. Urban centers, they say, surplus food storage, division of labor, long-distance trade, symbolic systems like writing or ritual. But even that list is slippery. Consider Çatalhöyük in modern-day Turkey. 9,000 years ago, people there built dense clusters of homes without streets, doors, or monuments. They climbed down ladders through the roofs. There was no clear ruling class, no palaces. Yet we call it one of the earliest cities. Why? Because what mattered wasn't the skyline, but the pattern. People living together, coordinating, persisting across generations. By that broader lens, civilization is less about skyscrapers and more about scale. It's the leap from surviving the day to organizing the future. It's storing grain for tomorrow, teaching myths to children, or digging canals so the next season's crops will grow. A termite mound, in that sense, has echoes of civilization ventilation systems, fungus farms, social roles. If you scaled it up, would we mistake it for a city? Possibly. Civilization might simply be collective persistence with a touch of imagination. Now, tilt that definition into deep time. If a non-human species organized itself, farmed, built, or engineered environments in subtle ways, it might count as a civilization by these terms. But here's the problem. Subtle civilizations vanish easily. Clay tablets last. Stone temples endure. But what if your entire infrastructure is woven reeds, communal songs, or living coral gardens? The Earth would absorb that within centuries, leaving almost nothing for geologists millions of years later. Think about our own blind spots. For decades, scholars argued whether the ancient Amazon supported complex societies. Dense forest seemed too wild, too unforgiving. But satellite imagery and soil analysis later revealed networks of geometric earthworks, enriched soils, and settlement traces hidden under trees. Entire cultures had been invisible until technology shifted our gaze. If we nearly missed them after just 1,000 years, how many civilizations might be lost after 100 million? Even our categories carry bias. We tend to equate civilization with permanent stone, metal, writing. But what if intelligence chose another path? A civilization might store knowledge biologically, passing it in altered DNA, or encode it in patterns of migration or song. It might shape ecosystems subtly, redirecting rivers, tending forests, sculpting coastlines, so that from a distance it looked like nature. Would we ever recognize that as intentional, or would we chalk it up to chance? It's humbling to realize that our criteria for civilization are tuned to us. We look for writing because we write. We look for cities because we live in them. But civilization could be quieter, networks of cooperation, cycles of ritual, or long-term stewardship of an environment. Imagine a civilization that chose to live in harmony so thoroughly that its traces blended into geology and biology. In the fossil record, that would look like nothing at all. This thought experiment matters because it changes how we search. If we assume civilizations always build pyramids or spaceports, we'll miss anything subtler. If we broaden our definition, if we see civilization as collective memory, ecological design, or patterned persistence, then the possibilities expand. Suddenly, the silence of the rocks is less reassuring, because silence may not mean nothing happened. Silence may mean we've been listening with the wrong ears. And here we are, perched in our fragile moment, building skyscrapers and satellites while still trying to agree on what civilization even is. Maybe it's enough to know that civilizations, like rivers, take many forms. Some roar with monuments, others flow quietly underground, but all, in their own way, are temporary arrangements of order in a restless world. So the next time you hear civilization, don't think only of stone pyramids or neon skylines. Think of termite mounds, rainforest earthworks, desert canals, coral gardens, and the countless other ways intelligence might organize itself. Civilization isn't a finish line. It's a spectrum, 1,000 ways of saying, we were here for a while. We imagine fossils as perfect skeletons laid in museums. But fossilization is rare. Most creatures are never preserved. Even with ideal conditions, millions of years usually turn bodies to dust. If bones can vanish, what chance would cities have? When you walk through a natural history museum, it feels like the earth is generous with its memories. Dinosaurs loom, mammoths pose, trilobites sit in glass cases, as though the planet kept a careful scrapbook. But that impression is misleading. The fossil record is not a complete diary. It's more like a handful of postcards rescued from a house fire. Most of the story is gone. Fossilization is, above all, an accident. To preserve a skeleton, the body must escape scavengers, decay, and erosion. It must be buried quickly, tucked away in sediments that shut out oxygen and bacteria. Then minerals must seep in, replacing bone molecule by molecule, hardening what was once soft and alive into stone. Even then, survival is no guarantee. Erosion may destroy the fossil before anyone finds it. Shifting tectonic plates may drag it into the mantle. Rivers may grind it to dust. That means the fossils we do have are the rarest of rare survivors. For every elegant skeleton mounted on display, there were millions of animals, plants, and microbes that left no trace at all. You, sitting there, are vastly more likely to disappear completely than to become a fossil. Statistically, your best chance is to die in a mudslide, be rapidly buried, avoid scavengers, and hope that over the next few million years, no mountain building event shreds your sedimentary bed. Hardly a comforting thought, but at least it keeps museum curators in business. Now consider what this means for civilizations. A city isn't one skeleton. It's millions of artifacts, structures, and materials. You might think that gives cities an advantage. More stuff, more chances to be preserved. But the opposite is true. Bones at least contain minerals that lend themselves to fossilization. Wood, fabric, paper, and plastic are far less durable. Even stone buildings crumble when weathered. After enough time, even the grandest monuments are ground down into grains indistinguishable from natural rock. Take a look at ancient ruins only a few thousand years old. Angkor Wat, Petra, Machu Picchu. Magnificent, yes, but already worn, swallowed by jungle, softened by erosion. Multiply that by 1,000,000 years, and they're not ruins anymore. They're soil, gravel, perhaps a faint discoloration in the earth. If bone, the hardest part of an animal, struggles to survive deep time, how could bricks and steel fare any better? Even the fossils we admire are rarely complete. Most are fragments, a tooth here, a femur there, a ripple of a footprint in sandstone. Paleontologists build entire species profiles from scraps. It's detective work conducted on the flimsiest evidence. If that's all we have of entire lineages that lasted millions of years, what are the odds of finding clear evidence of a civilization that might have lasted only a few thousand? And then there's luck. Fossilization is a lottery, and geology is a merciless ticket taker. Sometimes it preserves delicate feathers or insect wings in exquisite detail. Other times, entire ecosystems vanish without a trace. Whole epochs may be represented by nothing more than a few scattered impressions. Imagine how easily the traces of a lost civilization could be misfiled as natural oddities. The irony is that fossils aren't just rare, they're misleading. We picture dinosaurs as complete skeletons, but most museum mounts are mosaics, patched together from different individuals, filled in with educated guesses. If we can be fooled into thinking we have a clear picture of life from bones that are mostly missing, what confidence should we have in ruling out civilizations when their bones, cities, artifacts, technologies are infinitely less likely to fossilize at all? Here's the sobering perspective. The Earth is not a careful archivist. It's more like a distracted painter, layering and repainting its canvas over and over, leaving only faint ghosts of earlier sketches. Life rises, thrives, and almost entirely disappears. Fossils are exceptions, not the rule. The planet's memory is shallow, and it forgets far more than it remembers. So, when you look at a polished fossil in a museum case, imagine all the things you don't see: the unrecorded forests, the vanished herds, the civilizations that might have never left a mark strong enough to outlast rain and stone. The fragility of fossils reminds us permanence is a story we tell ourselves. In reality, almost nothing survives the eraser of time. Close your eyes. Picture the Earth's strata as shelves in a vast library. Most of the books have been burned. A few scraps remain charred, partial, sometimes misread. That's what fossils are. And if bones themselves struggle to persist, then cities, cultures, and entire civilizations might already have slipped into the void, erased without ceremony, lost except for the faintest whispers in stone. Even land is not safe. Tectonic plates drag, collide, and break. Mountains fold, valleys drown, deserts migrate. The face of Earth is restless, forever changing. What looks permanent in human time is fleeting in planetary time. From our perspective, continents appear eternal. Maps hang on classroom walls as if they were finished paintings. Mountains look like stone fortresses immune to change. But in reality, the Earth is more like a slow-motion kaleidoscope. The pieces are always moving, grinding, reshaping. We just live too quickly to notice. Take a mountain range. To us, the Himalayas seem immovable, a wall that has always split the sky. Yet geologists will tell you they are young, still rising, still rumbling as the Indian plate presses north into Asia. The mountains are not fixed monuments. They are wrinkles in a rug still being pushed. If you wait long enough, those wrinkles flatten. Even the tallest peaks crumble into sand, washed into rivers, carried to the sea. Valleys, too, refuse permanence. The land where a city thrives today may be a shallow bay in 1,000,000 years. Rivers change course, carving new paths, abandoning old ones. Floodplains rise, deltas vanish, shorelines migrate. Think of New Orleans, Venice, Jakarta, already threatened in centuries, not millions of years. In deep time, the question isn't if the land will change, but how dramatically. Deserts wander like restless nomads. The Sahara, which we imagine as timeless, was once green with lakes and grasslands. Paintings on cave walls show hunters chasing gazelle, where dunes now stretch to the horizon. Given enough time, the desert will shift again, spilling into new regions, shrinking from others. The map of Earth's climates is never still. It is always rewriting itself in dust, wind, and rain. And beneath all this, tectonics keeps its patient rhythm. The continents are rafts of crust drifting on a sea of molten rock. They crash together to form supercontinents, then tear apart into fragments, again and again. Pangaea was not the first, nor will it be the last. Before it came Rodinia, Nuna, Columbia. After it, something else, an as yet unnamed supercontinent that will gather hundreds of millions of years from now. This cycle has a strange consequence. Every few 100 million years, the surface of the Earth is effectively resculpted. Mountain chains rise and wear away. Ocean basins open and close. Old land is swallowed by subduction zones. New land pushed up in volcanic arcs. The crust is not a scrapbook. It is a chalkboard that insists on being reused. What does this mean for civilizations? It means that permanence is an illusion. A city built inland may survive longer than one built on a coast, but even it is at the mercy of earthquakes, floods, volcanoes, and glaciers. Over millions of years, its ruins may be lifted, buried, tilted sideways, or ground into gravel. The idea of forever does not belong to the Earth's surface. Even impact craters, gouged violently into the crust, soften with time. Look at the Chicxulub crater in Mexico, left by the asteroid that ended the dinosaurs. It is 66 million years old, ancient by our standards, but just a blink in geology. Already it is weathered, buried, eroded, harder to see. Multiply that times 5, 10, 20, and even scars that once shook the world can fade nearly to invisibility. For geologists, this impermanence is both frustration and joy. Frustration, because so much of Earth's story has been erased. Joy, because the very act of erasure is evidence of the planet's vitality. The Earth is not dead stone. It is a living, restless machine, constantly renewing itself. That restlessness is what makes it habitable, recycling carbon, forging landscapes, creating the diversity of life. But it leaves little room for archives. If a civilization had risen 500 million years ago, on land we now call ocean, or in mountains long since ground to dust, would we ever find it? Or would it, like so many tectonic seams, simply vanish into the churn? And here is the quiet truth. Permanence is a trick of perspective. A human life is short enough that mountains look eternal, rivers steady, deserts fixed. But stretch your view to planetary time, and everything writhes. The continents drift like rafts on a restless sea, and every landmark you know is temporary. So when you look at a map, don't see borders or continents frozen in place. See puzzle pieces mid-drift. See deserts poised to march, mountains preparing to collapse, valleys rehearsing their floods. The face of Earth is not finished. It is mid-sentence, and the story is still being written in stone. We treat the Grand Canyon as a geological archive, yet even it is missing entire chapters. Gaps in rock layers, called unconformities, remind us how much the planet forgets. If rocks can lose millions of years, civilizations could disappear without a trace. When you stand at the rim of the Grand Canyon, the first feeling is awe. The cliffs fall away into a rainbow of stone reds, browns, purples, creams, all stacked like the pages of the oldest book you've ever seen. Tourists lean against railings, whispering as though they've stepped into a cathedral. And in a sense, they have. This is Earth's Bible, written in layers of sediment, each band a chapter in a story that spans nearly 2 billion years. But here's the twist. Even this book is missing enormous sections. Entire epochs are gone, not torn out cleanly like a missing page, but smeared, eroded, overwritten. Geologists call these blank spaces unconformities. They are places where time itself is absent millions, even hundreds of millions of years, simply not recorded in stone. You're looking at the thickest diary ever kept, and yet half the entries are scribbled over, or never written at all. One of the most famous examples lies right there in the canyon walls, the Great Unconformity. In some spots, rock layers, only a few 100 million years old, sit directly on top of rocks, nearly 2 billion years old. Imagine picking up a history textbook that jumps straight from the Roman Empire to the internet age, with nothing in between. That's what geology does. The canyon's grandeur makes us think it remembers everything. But in truth, it is forgetful, patchy, prone to amnesia. Now apply that to civilizations. If the planet can lose 500 million years of geological history in a single gap, what chance does a city fragile, temporary, built of wood, clay, metal, have? Even if ruins once existed, they could easily be erased by erosion, buried under new sediments, or obliterated in the chaos of tectonic churn. The Grand Canyon shows us that the Earth doesn't just fail to remember, it actively forgets. We like to imagine the ground beneath our feet as stable, as though once something is buried, it will stay buried forever. But unconformities prove otherwise. Layers can be stripped away by rivers, glaciers, or wind before the next layers are deposited. It's like writing notes in sand while the tide rolls in. What survives depends less on what was there and more on the timing of erasure. Think of how archaeologists reconstruct human history. A broken pot shard here, a foundation stone there, a smear of charcoal in a cave. Entire cultures are pieced together from crumbs. And those are cultures only a few thousand years old, preserved in landscapes that happen to be relatively stable. Scale that up to millions of years, add in unconformities, and you see the problem. Civilization could exist, vanish, and then be overwritten by the planet's restless hand, leaving nothing behind but an empty interval. Even fossils, which we treat as the gold standard of preservation, are subject to these gaps. Whole species come and go between layers we do have. Their absence doesn't mean they never existed, just that the conditions for remembering weren't right. Civilization, being rarer and more delicate than species, would face even longer odds. The Grand Canyon is humbling because it offers perspective. On one hand, it reveals deep time in glorious color. On the other, it reminds us that our access to that time is riddled with holes. You can stand on the edge, gaze into the abyss, and feel like you're staring into eternity, but really, you're staring at a scrapbook with half its pages missing and coffee stains on the rest. And here's the sly part. We treat unconformities as mysteries to solve, but perhaps they are also lessons. The Earth is not designed to preserve everything. Forgetting is part of its process. It erases in order to recycle, clears space for new layers, new chapters. Permanence is not natural. Impermanence is. So, if we ever wonder why we don't see traces of lost civilizations in stone, the Grand Canyon gives us the answer. Even the grandest geological archive loses track of time. Even the most magnificent rock library has blacked out pages. Civilizations, like paragraphs in that story, could be written and erased without anyone knowing they were ever there. Next time you see a photograph of the canyon, notice the layers. Notice also the gaps. Those empty stretches of nothing are where millions of years slipped through the cracks. And if the Earth can forget its own mountains, rivers, and oceans, then it can certainly forget us. Stone crumbles, metal rusts, plastics decay in sunlight, even concrete eventually dissolves. The things we believe will outlast us might not even survive a fraction of Earth's age. What chance, then? For a civilization millions of years gone, we like to imagine permanence. A cathedral built of stone, a tower of steel, a bridge of concrete. We treat them as though they will stand forever. Tourists marvel at the pyramids or the Great Wall and call them timeless. Yet timeless in human speech means centuries, perhaps a few thousand years. In geological terms, it barely registers. Stone wears away, metal corrodes, and concrete, our miracle of modern engineering, crumbles if left untended. Time is a patient but merciless sculptor, and everything we build is eventually reduced to dust. Consider stone. It feels solid, immovable, but even granite weathers, given enough rain, frost, and root systems prying into cracks. Sandstone dissolves grain by grain. Marble statues lose their sharp features, their faces smoothed into anonymity. Walk through the ruins of ancient Greece or Rome and you see columns broken, inscriptions fading, details gone. Now imagine those ruins not after 2,000 years, but after 2 million. They would no longer be ruins. They would be sand, incorporated into new sedimentary layers, indistinguishable from the grains around them. Metal fares no better. Iron rusts quickly, swelling into flakes that crumble away. Bronze and copper corrode into green powders. Gold is more durable, but rarely used in bulk for construction. Even stainless steel has a limit. Salt air, acids, and time itself will wear it down. Think of shipwrecks, rusting hulks in shallow seas. Some barely survive a century before becoming twisted skeletons of themselves. Scale that to millennia, and nothing recognizable remains. And what about plastics, the signature of our age? We sometimes call them forever chemicals, but forever is optimistic. Sunlight breaks plastics into fragments. Waves grind them into microplastics. Soil microbes are slowly learning to digest them. Over millions of years, plastics won't sit intact like buried treasure. They'll break into molecules, indistinguishable from other hydrocarbons in the sediment. Our legacy of shopping bags and soda bottles might survive as a chemical signal in rocks, but not as artifacts anyone could pick up and wave around. Even concrete, which we like to think of as humanity's indestructible stamp, betrays us. Roman concrete has lasted 2,000 years, and engineers marvel at its resilience. But concrete is not eternal. It cracks under stress, crumbles when water seeps in, and eventually returns to gravel and lime. Skyscrapers left alone will collapse within centuries. Their skeletons may last a little longer, but 1,000,000 years is not a contest they can win. This raises a strange, almost humorous thought. If another civilization came before us, their monuments might already be dust, their tools corroded into nothing. They might have built with materials we consider durable, but the earth has no patience for durability. Against deep time, there are no indestructible materials, only temporary arrangements of atoms. Even our so-called records, our attempts to be remembered, are fragile. Books burn, paper decays, hard drives fail. A library buried under ash, like Pompeii, might survive for a few centuries, but after tens of thousands of years, gone. After millions, not even a whisper. Imagine some ancient civilization's equivalent of the Library of Alexandria. Its wisdom might have vanished twice over, first in fire, then in erosion. If artifacts cannot endure, what can? Some things leave ghostly echoes, chemical traces, isotopes, odd concentrations of minerals. Coal seams are evidence of ancient forests. A spike of iridium marks the asteroid that killed the dinosaurs. Perhaps the best evidence of civilization is not what it builds, but what it alters. Agriculture reshapes soils. Industry changes the atmosphere. Plastics scatter into oceans. These are the fingerprints that may persist, not the monuments we so proudly raise. That truth is humbling. We imagine ourselves as permanent actors in Earth's drama, but we are more like stage props built of paper. The Earth is the stagehand, endlessly repainting, replacing, and discarding sets. Civilizations rise, but the curtains always fall, and by the time the stage is reset, the props are gone. So when you walk past a skyscraper and crane your neck upward, think of it as a sandcastle on the edge of a tide. Impressive now, fleeting soon. The question is not whether it will last, but how long before the waves reclaim it. And if another civilization once stood where we stand, it too may have built its sandcastles, now erased beyond recognition. Artifacts against time. This is the contest we always lose. We win briefly, in decades, maybe in centuries, but in millions of years, the scoreboard resets. Dust claims the stone, rust claims the metal, sunlight claims the plastic, and the earth, patient as ever, writes over us with new landscapes. A carved stone might be a tool, or it might be the random product of erosion. Crystals form complex geometries. Rocks shape themselves into spheres. Without context, how do we tell natural from artificial? Would we even recognize the traces? This is one of the quietest tricks the earth plays on us. It is a master sculptor, endlessly creating forms that look deliberate, purposeful, even artistic, without ever intending them. Walk through a desert, and you may stumble on stones so smooth they seem polished by hand. Wander a volcanic field, and you'll see hexagonal columns of basalt rising like walls built by giants. Enter a cave, and crystals jut outward in perfect symmetry, each one a mathematical marvel that looks more engineered than mined. None of it is the work of tool makers. All of it is natural chemistry and physics, running on the clockwork of heat, pressure, and time. It makes archaeology tricky. The earliest stone tools humans recognize are often little more than chipped rocks. To an expert, a carefully flaked edge signals designs someone struck that stone with intent. But to the untrained eye, it might look like a rock that just fell the wrong way. For decades, researchers have argued over ambiguous finds. Is this a hand axe or just a funny-shaped pebble? Is that a burial site or a pile of rocks knocked down by gravity? When you're separated from the maker by hundreds of thousands of years, certainty is a fragile thing. Now stretch that to millions of years, or even tens of millions. If an ancient civilization existed, their artifacts would face the same scrutiny, only worse. A shard of pottery could be mistaken for a piece of cracked clay. A carved stone sphere might look like the natural concretions already found in riverbeds and deserts around the world. Even a metallic lump could be confused with a rare mineral deposit or an unusual meteorite. Without context, without a pattern, a single artifact might vanish into the background noise of geology. Nature, after all, is inventive. Think of the Moeraki boulders in New Zealand. Nearly perfect stone spheres, some taller than a person, scattered along the coast. They look like art, like ancient cannonballs, like sculptures rolled into place. In truth, they are concretions, natural growths of mineral around a core, slowly forming over millions of years. No chisels, no plans, just chemistry. Or, take pyrite, sometimes called fool's gold. In some conditions, it forms cubic crystals so sharp and precise that they look machined. Hold one in your hand, and it feels like a dice carved for some prehistoric board game. But no artisan made it. It grew that way, atom by atom. If we discovered such a cube in the wrong sediment layer, how would we know it wasn't technology? Even fossils can blur the line. Stromatolites, layered rock formations built by ancient microbial colonies, look like accidental architecture. Coral reefs resemble sculpted walls. Termite mounds, with their ventilation systems and towering spires, are indistinguishable from ruins. Once erosion takes away the insects themselves, nature builds, it engineers. Sometimes it does so, in ways that look suspiciously like our own work. This raises an unsettling possibility. Maybe we have stumbled upon the traces of something ancient, but we dismissed it as natural. Maybe a carved stone was catalogued as erosion. Maybe a geometric object was shelved as a crystal. Without a wider pattern, without multiple supporting finds, science errs on the side of nature. And rightly so, because nature can explain a lot. But the cost of that caution may be silence. It's a humbling reminder that intelligence does not have a monopoly on order. Patterns arise spontaneously. Shapes repeat themselves. A straight line or a perfect sphere doesn't prove intention. Only context does layers of evidence woven together into a story. Without that context, the Earth's clever imitations can make us second-guess even our own definitions of technology. Imagine future archaeologists, millions of years from now, digging through the remnants of our age. Suppose they find a smooth cylinder buried deep in rock. Is it a corroded pipe from an old city? Or is it a stalactite broken from a cave ceiling? Without the surrounding city, without the plumbing system, how would they know? What if they found a glittering microchip reduced to a mineral flake? Would they recognize it as once having carried code, or would it be filed away as an oddly metallic inclusion? This is the real challenge of looking for lost civilizations. It is not just that time erases, it is that nature blurs. Every trace we leave competes with natural lookalikes, and often the natural versions win the argument. So when we look for ancient civilizations, we must ask, would we even know if we had already found one? Or are we standing in museums and laboratories, holding their echoes in our hands, while calling them curiosities of geology? The line between artifact and accident is thin, and the earth walks it with deceptive grace. Our job, if we want to find what came before, is not just to dig deeper, but to look differently, to search not only for objects, but for the improbable patterns that make accidents less likely. Until then, nature will keep carving its clever imitations, leaving us to wonder what we're really seeing. If ruins fail, chemistry might hold the answers. Carbon isotopes, rare elements, synthetic compounds, traces in sediment that whisper, someone burned, mined, built. Like fingerprints smudged but not erased, they might survive even when structures don't. When we think of evidence for civilizations, we imagine towering monuments, broken pottery, rusting machines. But what if the real record isn't architectural at all? What if the truest archives are hidden in the chemistry of rocks and soils? Unlike stone or metal, which can crumble, chemistry leaves ghosts. Ratios, anomalies, and traces in the sediment remain, long after the visible world has gone. Take carbon isotopes. Plants prefer lighter carbon, carbon-12, when they photosynthesize. When humans burn fossil fuels, we release massive amounts of this lighter carbon into the atmosphere. The balance between carbon-12 and carbon-13 shifts, and that shift is locked into ice cores and ocean sediments. Future geologists, millions of years from now, might drill into a layer of rock and say, something odd happened here. Something was burning a lot of ancient plants all at once. That something would be us. Or think about nitrogen. Our fertilizers leave a chemical signature, too, altering the ratio of nitrogen isotopes in soils and waterways. This alteration doesn't happen naturally at the same scale. It's like painting with invisible ink that future scientists can still see. If another civilization farmed on an industrial scale long ago, perhaps their nitrogen signature lingers in some forgotten layer, misread as an odd natural event. Then there are the metals. Mining and smelting scatter unusual concentrations of elements: lead, mercury, copper, aluminum, into the ground and rivers. In the modern era, our aluminum is everywhere, though in nature, it's usually trapped in ores. If future geologists find a strange spike of processed aluminum in rocks, they might wonder whether it was natural lightning, forging it in a rare deposit, or whether someone, somewhere, had smelters and airplanes. Even stranger are synthetic compounds. Plastics break down physically, but chemically, they might leave traces of complex hydrocarbons not normally present. The same with refrigerants like CFCs, which damaged the ozone layer in the 20th century. These are molecules so unusual they almost shout artificial. If another civilization tinkered with chemistry in its day, it may have left behind markers that still hide in sediments, waiting to be recognized. Radioactive isotopes tell a similar story. Nuclear tests in the mid-20th century spread isotopes like cesium-137 and plutonium-239 across the globe. These don't occur in nature at those concentrations. A thin layer in future rocks will bear their signature. Even if our buildings collapse and our records vanish, the dirt itself will tell on us. Someone here was splitting atoms. This is why scientists like Gavin Schmidt and Adam Frank, in proposing the Silurian hypothesis, argued that we shouldn't just look for ruins of hypothetical ancient civilizations. We should look for chemical fingerprints. Civilizations may be ephemeral, but industry leaves smudges, And unlike stone or wood, those smudges sometimes last. The challenge, of course, is interpretation. Nature produces anomalies too. Massive volcanic eruptions alter carbon ratios. Meteor impacts scatter iridium across the globe. Methane releases can mimic greenhouse gas spikes. To distinguish civilization from catastrophe requires careful detective work, sifting through clues to decide whether they are the aftermath of geology or the work of geology's clever tenant, intelligence. It's easy to imagine false positives. Suppose future geologists discover a spike of carbon dioxide. Was it an industrial civilization or just a supervolcano? They find odd synthetic molecules. Were they truly artificial or the product of exotic chemistry deep underground? The record is ambiguous. It requires context, comparison, and humility. And yet, the thought persists. Maybe we've already seen these clues, buried in ancient strata, but dismissed them as natural. Maybe a spike of carbon here, a strange mineral concentration there, was once the fingerprint of someone long gone. Our bias, understandably, is to assume nature first. But what if that assumption has hidden whole histories from us? When you think of it this way, chemistry becomes a kind of whispering archive. Not bold monuments or carved inscriptions, but subtle ratios and residues. The earth may erase the walls, but it often leaves the soot in the air, the traces in the soil, the fingerprints pressed into rock. So, perhaps the best way to hunt for lost civilizations is not with shovels, but with spectrometers, not looking for statues, but for isotopes. The traces may be faint, smudged, and half erased, but they might be enough to say, someone was here. Someone burned, mined, built, altered, and the planet, however forgetful, still remembers in its chemistry. If ruins fail, chemistry might hold the answers. Carbon isotopes, rare elements, synthetic compounds, traces in sediment that whisper, someone burned, mined, built. Like fingerprints smudged but not erased, they might survive even when structures don't. When we think of evidence for civilizations, we imagine towering monuments, broken pottery, rusting machines. But what if the real record isn't architectural at all? What if the truest archives are hidden in the chemistry of rocks and soils? Unlike stone or metal, which can crumble, chemistry leaves ghosts. Ratios, anomalies, and traces in the sediment remain, long after the visible world has gone. Take carbon isotopes. Plants prefer lighter carbon, carbon-12, when they photosynthesize. When humans burn fossil fuels, we release massive amounts of this lighter carbon into the atmosphere. The balance between carbon-12 and carbon-13 shifts, and that shift is locked into ice cores and ocean sediments. Future geologists, millions of years from now, might drill into a layer of rock and say, something odd happened here. Something was burning a lot of ancient plants all at once. That something would be us. Or think about nitrogen. Our fertilizers leave a chemical signature too, altering the ratio of nitrogen isotopes in soils and waterways. This alteration doesn't happen naturally at the same scale. It's like painting with invisible ink that future scientists can still see. If another civilization farmed on an industrial scale long ago, perhaps their nitrogen signature lingers in some forgotten layer, misread as an odd natural event. Then there are the metals. Mining and smelting scatter unusual concentrations of elements: lead, mercury, copper, aluminum, into the ground and rivers. In the modern era, our aluminum is everywhere, though in nature it's usually trapped in ores. If future geologists find a strange spike of processed aluminum in rocks, they might wonder whether it was natural lightning forging it in a rare deposit, or whether someone, somewhere, had smelters and airplanes. Even stranger are synthetic compounds. Plastics break down physically, but chemically, they might leave traces of complex hydrocarbons not normally present. The same with refrigerants like CFCs, which damaged the ozone layer in the 20th century. These are molecules so unusual they almost shout artificial. If another civilization tinkered with chemistry in its day, it may have left behind markers that still hide in sediments, waiting to be recognized. Radioactive isotopes tell a similar story. Nuclear tests in the mid-20th century spread isotopes like cesium-137 and plutonium-239 across the globe. These don't occur in nature at those concentrations. A thin layer in future rocks will bear their signature. Even if our buildings collapse and our records vanish, the dirt itself will tell on us. Someone here was splitting atoms. This is why scientists like Gavin Schmidt and Adam Frank, in proposing the Silurian hypothesis, argued that we shouldn't just look for ruins of hypothetical ancient civilizations. We should look for chemical fingerprints. Civilizations may be ephemeral, but industry leaves smudges, and unlike stone or wood, those smudges sometimes last. The challenge, of course, is interpretation. Nature produces anomalies too. Massive volcanic eruptions alter carbon ratios. Meteor impacts scatter iridium across the globe. Methane releases can mimic greenhouse gas spikes. To distinguish civilization from catastrophe requires careful detective work, sifting through clues to decide whether they are the aftermath of geology or the work of geology's clever tenant, intelligence. It's easy to imagine false positives. Suppose future geologists discover a spike of carbon dioxide. Was it an industrial civilization or just a supervolcano? They find odd synthetic molecules. Were they truly artificial or the product of exotic chemistry deep underground? The record is ambiguous. It requires context, comparison, and humility. And yet, the thought persists. Maybe we've already seen these clues, buried in ancient strata, but dismissed them as natural. Maybe a spike of carbon here, a strange mineral concentration there, was once the fingerprint of someone long gone. Our bias, understandably, is to assume nature first. But what if that assumption has hidden whole histories from us? When you think of it this way, chemistry becomes a kind of whispering archive, not bold monuments or carved inscriptions, but subtle ratios and residues. The earth may erase the walls, but it often leaves the soot in the air, the traces in the soil, the fingerprints pressed into rock. So, perhaps the best way to hunt for lost civilizations is not with shovels, but with spectrometers, not looking for statues, but for isotopes. The traces may be faint, smudged, and half erased, but they might be enough to say, someone was here. Someone burned, mined, built, altered, and the planet, however forgetful, still remembers in its chemistry. If ruins fail, chemistry might hold the answers. Carbon isotopes, rare elements, synthetic compounds, traces in sediment that whisper, someone burned, mined, built. Like fingerprints smudged but not erased, they might survive even when structures don't. When we think of evidence for civilizations, we imagine towering monuments, broken pottery, rusting machines. But what if the real record isn't architectural at all? What if the truest archives are hidden in the chemistry of rocks and soils? Unlike stone or metal, which can crumble, chemistry leaves ghosts. Ratios, anomalies, and traces in the sediment remain long after the visible world has gone. Take carbon isotopes. Plants prefer lighter carbon, carbon-12, when they photosynthesize. When humans burn fossil fuels, we release massive amounts of this lighter carbon into the atmosphere. The balance between carbon-12 and carbon-13 shifts, and that shift is locked into ice cores and ocean sediments. Future geologists, millions of years from now, might drill into a layer of rock and say, something odd happened here. Something was burning a lot of ancient plants all at once. That something would be us. Or think about nitrogen. Our fertilizers leave a chemical signature too, altering the ratio of nitrogen isotopes in soils and waterways. This alteration doesn't happen naturally at the same scale. It's like painting with invisible ink that future scientists can still see. If another civilization farmed on an industrial scale long ago, perhaps their nitrogen signature lingers in some forgotten layer, misread as an odd natural event. Then there are the metals. Mining and smelting scatter unusual concentrations of elements: lead, mercury, copper, aluminum, into the ground and rivers. In the modern era, our aluminum is everywhere, though in nature, it's usually trapped in ores. If future geologists find a strange spike of processed aluminum in rocks, they might wonder whether it was natural lightning forging it in a rare deposit, or whether someone, somewhere, had smelters and airplanes. Even stranger are synthetic compounds. Plastics break down physically, but chemically, they might leave traces of complex hydrocarbons not normally present. The same with refrigerants like CFCs, which damaged the ozone layer in the 20th century. These are molecules so unusual they almost shout artificial. If another civilization tinkered with chemistry in its day, it may have left behind markers that still hide in sediments, waiting to be recognized. Radioactive isotopes tell a similar story. Nuclear tests in the mid-20th century spread isotopes like cesium-137 and plutonium-239 across the globe. These don't occur in nature at those concentrations. A thin layer in future rocks will bear their signature. Even if our buildings collapse and our records vanish, the dirt itself will tell on us. Someone here was splitting atoms. This is why scientists like Gavin Schmidt and Adam Frank, in proposing the Silurian hypothesis, argued that we shouldn't just look for ruins of hypothetical ancient civilizations. We should look for chemical fingerprints. Civilizations may be ephemeral, but industry leaves smudges, and unlike stone or wood, those smudges sometimes last. The challenge, of course, is interpretation. Nature produces anomalies too. Massive volcanic eruptions alter carbon ratios. Meteor impacts scatter iridium across the globe. Methane releases can mimic greenhouse gas spikes. To distinguish civilization from catastrophe requires careful detective work, sifting through clues to decide whether they are the aftermath of geology or the work of geology's clever tenant, intelligence. It's easy to imagine false positives. Suppose future geologists discover a spike of carbon dioxide. Was it an industrial civilization or just a supervolcano? They find odd synthetic molecules. Were they truly artificial or the product of exotic chemistry deep underground? The record is ambiguous. It requires context, comparison, and humility. And yet, the thought persists. Maybe we've already seen these clues, buried in ancient strata, but dismissed them as natural. Maybe a spike of carbon here, a strange mineral concentration there, was once the fingerprint of someone long gone. Our bias, understandably, is to assume nature first. But what if that assumption has hidden whole histories from us? When you think of it this way, Chemistry becomes a kind of whispering archive, not bold monuments or carved inscriptions, but subtle ratios and residues. The earth may erase the walls, but it often leaves the soot in the air, the traces in the soil, the fingerprints pressed into rock. So, perhaps the best way to hunt for lost civilizations is not with shovels, but with spectrometers, not looking for statues, but for isotopes. The traces may be faint, smudged, and half erased, but they might be enough to say, someone was here. Someone burned, mined, built, altered, and the planet, however forgetful, still remembers in its chemistry. Layers of mud at the bottom of seas, trap signals, climate shifts, extinctions, atmospheric changes. Some of those shifts might be natural, but what if one was not? What if a blip in chemistry marked not volcanoes or meteors, but industry? Think of the ocean floor as the Earth's filing cabinet. Every year, tiny particles drift downward, dust blown from deserts, the skeletons of plankton, ash from distant fires, even microscopic flakes from rocks on land. These sink slowly, layering themselves like pages in a scrapbook. Over tens of thousands of years, those pages thicken into mud, then into rock. And like any good filing cabinet, they preserve stories, climate changes, extinction events, shifts in the atmosphere. The ocean remembers, even when the continents forget. Ice cores are snapshots of the past few 100,000 years. Sediments go further, drill deep into the seafloor, and you can read millions of years of Earth's history written in mud. Pale colors might mark times of calm oceans. Darker bands might mark floods of organic matter. A thin layer, rich in iridium, reveals the day an asteroid struck, ending the age of dinosaurs. Each slice of mud is a time capsule, quiet and unassuming, yet packed with data. But like any archive, interpretation is key. A sudden spike in carbon dioxide might point to volcanic eruptions that filled the sky with ash. A trace of sulfur could tell of giant wildfires. A rise in heavy metals might mark a meteor impact. Yet, here's the haunting thought. The same signs could also come from industry. What if a spike of carbon was not just magma's breath, but smoke from factories? What if a concentration of metals wasn't the gift of a meteor, but the byproduct of ancient mining? This is the detective story of ocean sediments. They don't tell us who wrote the message, only that a message was written. When geologists sift through those cores, they're not just seeing natural cycles, they're searching for anomalies. A sudden warming, a chemical signature that doesn't quite fit, an unexpected shift in isotope ratios. These are the smudges on the page, the fingerprints left in the filing cabinet, and the ocean, vast and patient, is good at collecting fingerprints. It covers 70% of the earth. Rain and rivers carry soil, ash, and chemicals into it. Winds deliver dust across continents. Everything eventually finds its way to the sea. That means if a civilization existed even briefly, its chemical echoes might not survive on land, where erosion and tectonics erase them, but they could be quietly archived in ocean mud. Even our own traces are already being written into those sediments. Plastics are settling into the sea floor, mixing with silt. Industrial metals have spread across oceans, carried by currents. Carbon from our factories and cars has shifted atmospheric balances, which are now locked into the skeletons of tiny marine organisms. Someday, millions of years from now, a core sample drilled from the seabed will show a thin layer, the Anthropocene, the moment when humans made the ocean remember. But here's the unsettling symmetry. If we can see our fingerprints, Could someone, long before us, have left their own? A blip of warming millions of years ago, a peculiar ratio of isotopes, a spike of metals where no meteor should have struck. These might be shrugged off as natural quirks, but what if they were not? What if buried deep in the seafloor is a chemical anomaly that whispers of industry older than we dare imagine? The trouble is, the ocean is both a generous archivist and a clumsy one. While sediments preserve, they also smear. Layers can blur together under pressure. Bioturbation, the stirring of sediments by burrowing creatures, mixes signals like fingerprints smudged across a page. Reading a core isn't like reading a book. It's like trying to reconstruct a novel from a handful of half-burned sentences. Still, even smudges tell stories. A sudden extinction layered in mud tells us something catastrophic happened. An abrupt climate shift recorded in shells of plankton tells us the world changed quickly. If an industrial civilization left behind chemical chaos, spikes of carbon, plastics turned to residue, radioactive isotopes, they might still lie waiting in those layers. We just haven't connected the dots. So the next time you picture the ocean floor, don't see an empty plain of mud. See a library, its shelves stocked with thin, dusty books, some pristine, some damaged, some missing pages. Among those books might be a volume with no title and no author. Its words cryptic. Was it volcanoes? Was it a meteor? Or was it someone, long ago, burning, mining, and building before the ocean quietly closed its drawers? The sediments won't answer outright. They never do. But they hold the possibility, and in that possibility lies the most haunting thought of all. Perhaps the ocean has already filed away the story of civilizations we will never meet, preserved in mud, waiting for a reader brave enough to wonder if nature had company. Not every civilization looks like ours. Some human ones left no skyscrapers, no written records, yet they endured for centuries. Perhaps a forgotten species organized itself differently through biology, rituals, or patterns we wouldn't even name civilization. When we imagine civilizations, our minds leap to skylines, towers gleaming in the sun, grids of roads, bridges over rivers, and digital lights flashing in the night. But this is only one way, our way. It's an accident of culture, technology, and available materials. History shows us that civilization doesn't need skyscrapers to exist. It can thrive in mud brick houses, in stone circles, in forests and plains, with no single monument left behind. Take Çatalhöyük in modern-day Turkey. No streets, no palaces, no statues, just clusters of houses packed tightly together, entered through rooftop doors. People lived there for centuries, sharing rituals, food, and labor. To archaeologists, the pattern itself, the density, the persistence, is what signals civilization. Or think of the mound builders of North America, who raised vast earthen structures that look, from a distance, like natural hills. For centuries, no one thought they were artificial. Yet they represented organized societies, capable of engineering projects on enormous scales. Civilization, then, is less about architecture and more about patterns, shared labor, collective memory, rituals repeated across generations, a system larger than individuals, outlasting them, shaping the environment and being shaped by it in turn. That is civilization, even if no stone survives, even if no alphabet is scratched into clay. If this is true for humans, it could be true for others. A forgotten species might have organized its world through biology rather than buildings. Imagine a society of intelligent creatures that encoded knowledge in genetic memory, not in books. To us, their traces would vanish once they did. Or imagine a species whose civilization was ritualistic rather than material, expressed in seasonal gatherings, migrations, or collective behaviors that left only faint environmental marks. If they lived in rainforests, their settlements might be compost within centuries. If they built with wood, their cities would vanish like fallen trees. Even in the present, we find ourselves fooled. Termites build mounds with internal ventilation systems. Fungus farming ants cultivate crops underground. To us, these are colonies, not civilizations. Yet they meet many of the same criteria: organized labor, resource management, environmental engineering, communication, resilience. If termites were larger, if ants lived long enough to write their history, we might call them a civilization. Instead, we dismiss them as instinct-driven. Perhaps that's our bias talking. And then there is the question of language. Writing is not inevitable. Many enduring human cultures never developed alphabets or scripts. Their civilizations were oral, embodied in ritual and memory. If such a society vanished, we would never read its archives. Its wisdom would dissolve with the people who carried it. How many times might this have happened before humans arrived? A civilization could rise, flourish for thousands of years, and disappear without a trace, simply because it left no monuments, no carved stone, no durable technology. We should also remember that intelligence doesn't need to look like ours. Dolphins have complex societies with alliances, dialects, even names for individuals. Crows remember faces, use tools, and teach their young. Octopuses manipulate their environment in clever ways. None of these creatures build skyscrapers. But if given deep time, could some lineage of them have scaled up their intelligence into something resembling a civilization? If they did, how would we recognize it in the fossil record? Perhaps we wouldn't. Civilization, in this wider view, is a spectrum. At one end, loose cooperation, bands of hunters, tool users, animals with social bonds. At the other, planetary-scale engineering. Between them lie countless possibilities. Some build pyramids, some build rituals, some build nothing tangible at all, yet all leave patterns of persistence, of organization, of lives woven together. This perspective should humble us. Our criteria for civilization, cities, writing, monuments, are human filters. We look for ourselves in the past, and when we don't see a reflection, we assume there is nothing there. But the truth might be stranger. Entire civilizations could have existed, defined by rules we do not recognize, organized in ways that left no evidence we know how to read. So as we search for traces in the rocks, in the mud, in the chemistry of the air, perhaps we should widen our lens. Civilization need not be skyscrapers. It might be patterns of growth, or knowledge embedded in biology, or rituals lost to time. The spectrum is vast, and the earth is patient. And if others once walked it before us, they may have left behind more than we think, just not in forms we're trained to notice. To us, a termite mound is dirt, but scaled up, it's air-conditioned architecture, farming, climate control. Without knowing better, we'd call it natural. Could an ancient civilization's remains look so ordinary that we'd never know? Termite mounds are one of Earth's most humbling reminders that sophistication does not always look sophisticated. At a glance, they are just lumpy towers of mud and clay, scattered across savannas or tucked away in forests. A child might mistake them for oddly shaped hills. A hurried traveler might not notice them at all. But inside, life is buzzing literally. The mound is a living machine, a piece of environmental engineering so advanced it keeps millions of termites alive in harsh conditions where they should not thrive. Step inside. If you could shrink small enough, and you would find winding passageways, chambers for nurseries, fungus gardens for farming, shafts for ventilation. The mound breathes, pulling in air at one point, pushing it out at another. Heat disperses, humidity stabilizes. It is, in every sense, an air-conditioned skyscraper built of dirt. The architects? Tiny, blind insects, none of which can see the whole design. The blueprint exists only in their collective behavior, in instincts honed by evolution, and in the quiet rhythm of millions acting as one. If we stumbled across the ruins of such a structure millions of years from now, its spires worn down, its walls hardened into rock, would we recognize it for what it was? Or would we catalogue it as a strange natural formation, another geological oddity in a world full of them? That question haunts the search for lost civilizations, not because we expect termites to become architects of history, but because termites show us how easily intelligence can hide in plain sight. Scale this thought experiment upward. Imagine a species that built with earth, clay, or plant matter materials that erode quickly and blend seamlessly into the environment. Over time, those structures would crumble and vanish into soil. Without context, without surviving patterns, we dismiss them as hills, as dunes, as ordinary dirt. Civilization doesn't need concrete and steel. It might leave behind nothing but faint anomalies in the ground that look too ordinary to question. We already see this challenge in archaeology. Ancient Amazonian societies engineered entire landscapes, canals, causeways, orchards planted in geometric patterns. For centuries, dense forests reclaimed them, and outsiders assumed the region had always been wild and untouched. Only with satellite imaging and painstaking excavation did we realize people had been shaping the forest for millennia. Civilization hid inside nature, camouflaged by time. The termite mound is a metaphor for this blindness. When we look for civilizations, we expect monuments, we expect pyramids, or city grids. But perhaps the signs are subtler: modified soils, managed ecosystems, biological partnerships with plants or fungi. To us, they might look like natural landscapes, just as termite mounds look like dirt. But underneath lies intention, design, and cooperation. There's also the lesson of humility. Termites are not human. They do not hold conferences or write epics, yet their colonies display collective intelligence, resilience, and environmental mastery. If intelligence can organize in such unfamiliar ways today, who's to say it couldn't have done so in the deep past? Perhaps an ancient civilization, unimaginably different from us, built structures or systems that to our eyes appear as nothing more than geology. Consider stromatolites, layered rock formations created by microbial mats billions of years ago. They look like lumps of stone, but they are the fossilized cities of microbes, vast colonies shaping their environment through photosynthesis. If microbes could build something that endures for billions of years, then why not imagine larger, more complex beings, leaving traces that simply resemble ordinary geology? This thought experiment brings us back to the termite mound, the idea that what looks natural may not be entirely so. Nature and civilization are not opposites. They blur into each other. A termite mound is both natural and engineered, both dirt and design. The same might be true for any lost civilization. Their ruins may not look like ruins. They may look like hills, valleys, reefs, or mineral deposits, features we label natural. simply because we do not have the context to label them otherwise. And perhaps that's the sobering truth. Evidence of an ancient civilization could be scattered all around us, but our categories, our assumptions, prevent us from seeing it. Just as a traveler glances past a termite mound and sees only dirt, we might glance past their legacy and see only geology. So the termite mound gives us a lesson in perception. Intelligence can be quiet, disguised, ordinary. Civilization can look like dirt. And unless we widen our imagination beyond pyramids, beyond skyscrapers, beyond even our definitions of civilization, we may miss the whispers of others who once shared this earth. Civilizations don't need long to alter the earth. We humans have reshaped the planet in just a few hundred years of industrial activity. If another species had its moment, would its signal linger, faint but detectable? When we imagine civilizations, we tend to picture them unfolding over thousands of years, empires rising and falling, monuments weathering in deserts, dynasties stretching across centuries. But the truth is, you don't need millennia to make a planetary mark. You just need intensity. Think about us. In less than 3 centuries, we've rerouted rivers, lit the night sky with cities visible from orbit, and flooded the atmosphere with gases that change the climate. On geological timescales, this is a blink, a sneeze, the brief scratch of a pen. And yet, the scratch shows up in the Earth's record. That's the sobering part. Duration is not required for impact. A civilization lasting only a few hundred years, barely a rounding error in deep time, could still leave a signal in sediments, in chemistry, in climate. You don't need a million years of pyramids. You just need a concentrated burst of activity, and the planet takes note. Consider the Anthropocene, the proposed new epoch marked by human influence. In just a short span, we've created chemical signatures, plastics, radioactive isotopes, fertilizer residues that future geologists will see as sharp anomalies in the record. It's the geological equivalent of a highlighter mark across the page. Even if our cities crumble and our bones vanish, the highlight may remain, faint but distinct. This idea opens a strange possibility. If another species had its moment, brief, intense, industrial, its traces might still linger in the archives of the Earth. A spike of carbon dioxide here, a peculiar cluster of synthetic-looking molecules there, a sudden extinction ripple in the fossil record. We might already be looking at these things without recognizing their origin. After all, the geological record is a messy notebook. Volcanoes, impacts, and natural climate shifts leave marks too. Differentiating an artificial blip from a natural one isn't easy. But we know from ourselves that the timescale doesn't need to be grand. A few centuries are enough. Imagine a civilization of aquatic beings that discovered fossil fuels in their coastal world, burned through them rapidly, and then vanished, perhaps through disaster, perhaps through simple decline. Their Anthropocene might be long gone, but the thin layer of carbon anomalies, enriched nitrogen, or rare metal concentrations could still sit buried in mud. To us, it might look like an unexplained warming event or a curious chemical glitch. Without context, we'd shrug and label it natural variation. Duration, then, is not the main barrier to detection. The real challenge is interpretation. Signals blend together, overlap, and erode. A civilization might flare brightly, leave its mark, and fade all within a few thousand years while the record around it smears those signals into ambiguity. What we read as volcanic ash might once have been industrial smog. What we call rapid warming, might once have been the byproduct of engines and furnaces. Think of it this way. Civilizations are like campfires. Some burn long and steady, others flare up, blaze brilliantly, and collapse quickly into ash. Either way, they leave behind traces: scorched earth, charcoal, altered soil. Even a short-lived fire changes its surroundings. The question is whether, after eons of wind and rain, you can still recognize the fire for what it was. Our own history should remind us of this fragility. In just a few centuries, we've shaped the biosphere, but our ruins will not last. Skyscrapers will topple, satellites will fall, concrete will crumble. What will endure are subtler things: isotope ratios, synthetic molecules, radioactive dust, a geological highlight pen, faint but persistent. If this is true for us, why not for others? So, the problem of duration is a problem of humility. Civilizations do not need long to matter. They only need long enough to alter the balance of chemistry and climate. The record they leave might be thin, a whisper in the strata, but whispers are enough for those who know how to listen. The trouble is, we don't always recognize whispers when we hear them, which leaves us with a tantalizing possibility. Maybe the Earth's rocks already hold evidence of other campfires, other brief flares of intelligence. Maybe we've mistaken them for volcanic seasons, for meteor winters, for random spikes in the great breathing of the planet. Duration doesn't decide permanence, intensity does. And intensity leaves its echo, no matter how brief the voice that made it. Archaeology works with fragments: a flint blade, a pottery shard, a faint discoloration in soil. If we reconstruct our own past from scraps, imagine how faint the trail would be for a civilization millions of years old. The practice of archaeology is a humbling exercise in imagination. Entire stories of human history are pieced together from the smallest clues: a scatter of bones, a decorated pot, a fire pit turned to ash. Sometimes the evidence is so sparse that it feels like reconstructing a novel from 3 burned pages and a bookmark. Yet somehow, from those scraps, we tell stories of migration, trade, belief, and daily life. Humanity's past is stitched together from holes and tatters, with more silence than sound. Consider the famous site of Çatalhöyük. Archaeologists didn't find towering monuments. They found traces of mud brick houses, worn figurines, ash layers. From these, they inferred patterns of ritual and living. Or think of Stonehenge, a ring of stones left behind, stripped of roofs, walls, or any context. The stones themselves are mute. Only by comparison, by inference, by sheer persistence, do we begin to imagine what they meant to the people who placed them. Now zoom out in time. If reconstructing a few thousand years of human prehistory is already this fragile, what chance would we have with a civilization millions of years old? Even our best preserved ruins fade fast. Angkor Wat, abandoned for just a few centuries, was nearly consumed by the jungle. Cities in deserts vanish under dunes in less than a millennium. Metals corrode, wood rots, concrete crumbles. Within a geological blink, most of what we build becomes unrecognizable. This is the blind spot built into the earth. Preservation is rare. Fossilization requires rapid burial, the right chemistry, protection from erosion. Artifacts survive by accident, not by design. Most of the past, even the recent past, is gone for good. The famous fossil record is not a record at all. It's a patchwork scrapbook, missing most of its pages. For every species we know, there are dozens more that left no trace. For every culture we've glimpsed, Countless others are lost to fire, flood, or silence. Archaeologists accept this with a kind of stoic patience. They know they are working with fragments. That much will never be known. But when we extend this thinking into deep time, the implications become staggering. If an earlier civilization rose long before us, say, 10 million years ago, the odds of us finding clear evidence are vanishingly small. Their cities, their tools, their rituals would have dissolved into the soil. Even bones might be gone. What would remain? Perhaps a chemical anomaly in sediments, perhaps nothing at all. And here's the irony. We ourselves may one day be reconstructed the same way. Imagine future archaeologists, whether human descendants or something entirely different, trying to piece together our civilization. They might find a shard of plastic, degraded beyond recognition, a thin band of radioactive isotopes, a layer of unusual carbon in rocks. From those scraps, they would try to tell our story. And just as we speculate wildly about the meaning of an ancient carving, they might speculate wildly about us. Maybe they would conclude we were brief and unremarkable. Maybe they'd miss us entirely, seeing our signals as natural quirks. Maybe they'd build a narrative where volcanic eruptions explain what was really industrial pollution. Our story, like those we chase today, would be full of blind spots. This is not pessimism, it's perspective. Archaeology teaches us that the record is never complete, never whole. Each discovery is precious precisely because it is so improbable. The survival of a pot, a carving, a skeleton, it's a miracle of conditions aligning just right. The blind spots aren't mistakes. They are the natural state of history on a restless planet. And so, when we ask whether civilizations might have existed before us, we must keep the blind spots in mind. We may be looking for ruins where none remain, expecting architecture where only chemistry could persist. We may already be holding scraps of evidence without realizing it, misfiled as natural curiosities. Just as termites fool us with their piles of dirt, or Amazonian earthworks once hid beneath forests, so too could an ancient civilization hide in plain sight, obscured not by secrecy, but by the Earth's efficient recycling. To work with fragments is to accept humility. Archaeologists squint at a piece of pottery and reconstruct a feast. They study a discoloration in soil and imagine houses long gone. If they can do this with scraps just a few thousand years old, what might be forever beyond our reach? Perhaps the grandest civilizations of the past are invisible not because they never existed, but because the fragments that proved them simply didn't survive. The blind spots, then, are not gaps we can someday fill. They are reminders that absence is the rule, and presence the rare exception. To search for lost civilizations is to peer into silence, knowing that most stories vanish, and only a lucky few leave whispers. And maybe, just maybe, in one of those whispers lies the echo of neighbors we'll never meet. The ocean floor, on average, is younger than the last dinosaurs. Entire landscapes are swallowed and melted back into mantle. If a civilization left its legacy there, the Earth has already eaten it. It is strange to think that most of the planet we live on is so young. The continents feel ancient, immovable, eternal. But the ocean floor, the very surface beneath 70% of Earth's water, is a restless, temporary skin. On average, it's no older than 200 million years. That may sound vast, until you remember the Earth is 4.5 billion years old. 200 million is a late chapter in a very long book. The ocean floor has been written, erased, and rewritten countless times. This rewriting happens through a process called subduction. Picture the Earth's crust as a giant conveyor belt. At mid-ocean ridges, new seafloor is born, molten rock cooling into basalt as it pushes outward. But the conveyor doesn't just build, it recycles. At the edges of oceans, old crust dives back into the mantle, slipping beneath continents and vanishing into heat and pressure. What goes down doesn't come back in recognizable form. Cities, mountains, coral reefs, if they were on that slab, they melt into magma, erased not just from sight but from existence. This is why the oldest ocean crust we find is younger than the dinosaurs. Anything older has already been swallowed. Imagine, then, a civilization thriving on some ancient coastline, its towns scattered across islands, its people navigating seas long vanished. If their ruins were caught in the jaws of subduction, they are gone, not buried, not hidden, gone. The planet ate them, digested them, and used their atoms to build new rock. It's a sobering thought. We like to imagine ruins buried under sands, waiting for discovery. But the ocean floor offers no such patience. It doesn't preserve, it consumes. Entire landscapes, mountains, valleys, plains slip into trenches and are pulled under continents. In their place, new landforms rise, fresh crust spreads, and the cycle continues. If a civilization left its legacy there, the earth has already licked the plate clean. And yet, there's a paradox. While the crust itself is recycled, the chemistry it carried sometimes lingers. Subduction zones can bring elements into volcanic systems, releasing gases and minerals back into the air. A trace of civilization might survive not as ruins, but as altered chemistry, tiny anomalies in isotopes, faint signatures in volcanic rocks. It's like tearing up a letter, burning the pieces, and scattering the ashes in the wind. The words are gone, but if someone looked closely enough at the ash, they might guess a letter once existed. This raises a strange possibility. What if some of the odd chemical fingerprints we find in rocks, spikes of carbon, unusual metal deposits, are not only natural phenomena? What if they are the last whispers of civilizations erased by subduction? The odds are low, of course. Volcanoes and impacts can mimic such signals, but the thought lingers. The ocean floor has already forgotten more than we can ever know. The fragility of coastal civilizations today highlights this. Our greatest cities, New York, Tokyo, Shanghai, hug shorelines. If subduction erased coastlines millions of years from now, most of our monuments would vanish into the mantle. Future geologists might never know we existed, save for a faint chemical oddity. The Eiffel Tower, swallowed. The Statue of Liberty, gone. Las Vegas, pulled under like a bad magic trick. The ocean is the ultimate magician, making entire landscapes disappear without applause. This constant erasure also explains why the continents feel so much older. Unlike ocean crust, continental crust resists subduction. It floats, too buoyant to be pulled under easily. That's why we still see cratons billions of years old in Canada, Greenland, and Australia. If civilizations want to leave enduring scars, they'd have better luck inland, on stable continental rock. Oceans, by contrast, are merciless editors, trimming history down to nothing, and yet we are drawn to the sea. Civilization after civilization has built along coasts, trading across water, fishing its depths, telling stories of its power. Perhaps this is our great irony. We anchor our lives to the very parts of the planet most likely to forget us. So when we imagine lost civilizations, we should not only look to deserts, mountains, or caves. We should also imagine the countless worlds the ocean has already erased. Cities that rose and fell on sea floors long since swallowed. islands that flourished and vanished without trace, entire cultures consumed by the slow, patient hunger of subduction. The Earth is a forgetful host. It writes and rewrites its surface with fire and water. The ocean floor, in particular, is an etch a sketch, constantly shaken. Whatever was drawn there is gone. If others once walked those vanished coasts, if they dreamed, built, sang, or argued about taxes, the earth has already taken their memory into the deep, and from the mantle's heat, it forged new crust, ready for the next chapter, with no hint of the last. Look at our own age. Plastics, concrete, nitrogen, radioactive dust. These are the signals we are writing into geology. If someone digs us up millions of years from now, these will be our fossils. But how long will they last? We often imagine our legacy in terms of monuments, skyscrapers, cathedrals, bridges that gleam against the sky. But in the scale of geology, those are fragile shells. Wind, rain, frost, and roots will pull them apart. Steel rusts, glass shatters, concrete crumbles. Within tens of thousands of years, most of our cities will be rubble. Within 1,000,000, they will be soil. What truly endures are not our skylines, but the chemical fingerprints we scatter across the earth. Plastics, for instance, every bottle, bag, and fragment we've ever tossed away is finding its way into sediments. Beaches now hold grains of plastiglomerate, rocks fused with melted plastic. Oceans cradle microscopic polymers drifting in currents. Bury these under layers of sand, and in a few million years, they may appear as thin, colorful streaks in stone, a curious layer future geologists might scratch at with puzzled expressions. Our fossil record may not be bones or temples, but the stubborn chemistry of synthetic waste. Then there's concrete. We pour it by the gigaton, enough to outweigh all living plants on Earth. It feels eternal underfoot, but geology is less impressed. Rain seeps in, cracks spread, minerals reorganize. Over millions of years, most concrete will dissolve back into limestone-like material, leaving behind unusual formations rich in calcium and sand. A geologist millions of years from now may hold a chunk of ancient cement and wonder why this rock looks so oddly uniform, so deliberately mixed. It would be our ghost in their hand. Nitrogen is another signature. Our fertilizers have altered the planet's nitrogen cycle more than any natural process in eons. This shift is locked into soils, rivers, and sediments. 1,000,000 years from now, geochemists might notice a sharp, peculiar nitrogen spike in layers dating back to our time. They could interpret it as evidence of massive agricultural expansion, or, perhaps, mistake it for some strange natural event. Either way, our farming habits will echo far beyond our fields. And then, the most dramatic of all, radioactive dust. Nuclear weapons and accidents have seeded isotopes across the globe. Some decay quickly, but others linger for tens of thousands of years, their half-lives stretching into deep time. In the distant future, they may serve as unmistakable time markers, tiny glowing bookmarks pressed into Earth's pages. If anyone digs through the strata, these isotopes will be like neon arrows pointing straight to us. Something happened here, they will say. Taken together, these signals form what geologists now call the Anthropocene, the epoch of humans, an age defined not by fossils of species, but by the artificial geochemistry of a single civilization. We are writing ourselves into the rocks, though not in the ways we once imagined. Our pyramids and paintings will fade, but our plastic crumbs, our fertilizer spikes, our radioactive dust that is our enduring script, But here's the unsettling question. How long will it last? Plastics may survive millions of years, but subduction will eventually drag even those layers into the mantle. Concrete will weather into dust. Radioactive isotopes will decay, their signals fading to silence. Over tens of millions of years, most of our markers will thin out, blur, and finally vanish. The Earth is patient. It erases even the deepest scars. So, perhaps our Anthropocene layer will be like a whisper in the rock record, loud for a while, then muffled, then gone. A thin smear of odd chemistry between ancient stone above and below. If another civilization sifts through the archives, they may see us only as a strange anomaly, a brief pulse of plastics and isotopes that appeared, flickered, and disappeared. They might never know the details, the skyscrapers, the songs, the fears and joys, just the chemistry, stripped of story, and maybe that is fitting. For all our noise, all our ambition, we are part of Earth's endless palimpsest. We write ourselves into geology, even as geology prepares to overwrite us. The Anthropocene is our mirror, showing not just what we leave behind, but how fleeting we really are. And so we circle back. Would we even know? Maybe the Earth was quieter than we think, or maybe its silences are filled with stories we no longer hear. Civilizations may not vanish cleanly. They may simply dissolve into the background noise of geology. The question is both simple and unsettling. We long for certainty. Did others come before us? Were we truly the first to mold the Earth in ways that echo across epochs? Yet geology does not hand us clear answers. Instead, it hands us riddles, half-legible inscriptions written in stone and ash. For every layer that reveals a truth, another conceals one. Think of Earth's history as a vast orchestra. Volcanoes thunder, asteroids crash, symbols, oceans hum their steady bass. Against this roaring background, a civilization's melody might sound like a flute, bright, brief, then drowned out. Once the flute falls silent, the echoes fade into the music of the planet itself. When we listen later, can we be sure there was ever a melody at all? Or do we only hear the orchestra? That is the humility the Earth demands. We see silence and call it emptiness, but perhaps it is only that the signal has blurred. Civilizations, if they existed before us, may not have left monuments tall enough, or chemical traces distinct enough to be heard above the noise. Their ruins may lie beneath mountains, their isotopes scattered thin, their fossils lost to erosion. Like a message written on sand, all it takes is a few waves, and the letters dissolve back into the beach. And what of us? One day, we too will fade into the background hum. Our plastics, our concrete, our isotopes, all sharp now, all striking will erode, blur, sink. In 10 million years, our layer may be a faint smudge, discernible only to those who know exactly where to look. In 100 million, perhaps not even that. We like to imagine permanence, but permanence is an illusion whispered by short-lived creatures. This does not make the question futile. On the contrary, it makes it richer. To ask whether we would even know is to admit the limits of our perspective, to recognize the silence not as emptiness, but as possibility. It is to acknowledge that Earth's history may be deeper, stranger, and more populated with experiments in intelligence than we dare assume. And perhaps the real story is not whether we can prove such civilizations existed. Perhaps the story is in the listening itself, in the act of squinting at anomalies, of questioning our assumptions, of peering into stone for voices too faint to hear clearly. The humility to admit we might miss them is what ties us to the search. There's a quiet humor in this, too. We, a species that loses car keys daily, are trying to detect a civilization that may have ended 200 million years ago. We misplace our glasses, then claim we could find the fingerprints of ancient industry buried beneath mountains. Perhaps we will, perhaps we won't. But the attempt is its own kind of poetry, a reminder that curiosity can reach across not only oceans and planets, but epochs. So the question remains, lingering like a soft echo, would we even know? Maybe the Earth was truly silent before us, an unbroken wilderness of tectonics and tides. Or maybe it was not silent at all, but filled with fleeting choruses, civilizations that rose, sang their verse, and were erased, yet not erased completely. Their traces may still vibrate faintly, like the last shimmer of a bell after it is struck. We may never resolve it. That is the beauty and the ache of deep time. The Earth does not care to give us closure. It only turns its pages, writes new lines over old ones, and leaves us to puzzle at the margins. Our job is not to demand answers, but to keep listening, to keep asking, to lean close to the silence and wonder what it might be hiding. In that sense, the question that remains is not only about past civilizations, it is also about us, about how we choose to listen, how we choose to imagine, how we choose to mark our own brief chapter in the geology of time. And so we circle back. Would we even know? Maybe the Earth was quieter than we think, or maybe its silences are filled with stories we no longer hear. Civilizations may not vanish cleanly. They may simply dissolve into the background noise of geology. The question is both simple and unsettling. We long for certainty. Did others come before us? Were we truly the first to mold the Earth in ways that echo across epochs? Yet geology does not hand us clear answers. Instead, it hands us riddles, half-legible inscriptions written in stone and ash. For every layer that reveals a truth, another conceals one. Think of Earth's history as a vast orchestra. Volcanoes thunder, asteroids crash, symbols, oceans hum their steady bass. Against this roaring background, a civilization's melody might sound like a flute, bright, brief, then drowned out. Once the flute falls silent, the echoes fade into the music of the planet itself. When we listen later, can we be sure there was ever a melody at all? Or do we only hear the orchestra? That is the humility the Earth demands. We see silence and call it emptiness, but perhaps it is only that the signal has blurred. Civilizations, if they existed before us, may not have left monuments tall enough, or chemical traces distinct enough to be heard above the noise. Their ruins may lie beneath mountains, their isotopes scattered thin, their fossils lost to erosion. Like a message written on sand, all it takes is a few waves, and the letters dissolve back into the beach. And what of us? One day, we too will fade into the background hum. Our plastics, our concrete, our isotopes, all sharp now, all striking will erode, blur, sink. In 10 million years, our layer may be a faint smudge, discernible only to those who know exactly where to look. In 100 million, perhaps not even that. We like to imagine permanence, but permanence is an illusion whispered by short-lived creatures. This does not make the question futile. On the contrary, it makes it richer. To ask whether we would even know is to admit the limits of our perspective, to recognize the silence not as emptiness, but as possibility. It is to acknowledge that Earth's history may be deeper, stranger, and more populated with experiments in intelligence than we dare assume. And perhaps the real story is not whether we can prove such civilizations existed. Perhaps the story is in the listening itself, in the act of squinting at anomalies, of questioning our assumptions, of peering into stone for voices too faint to hear clearly. The humility to admit we might miss them is what ties us to the search. There's a quiet humor in this, too. We, a species that loses car keys daily, are trying to detect a civilization that may have ended 200 million years ago. We misplace our glasses, then claim we could find the fingerprints of ancient industry buried beneath mountains. Perhaps we will, perhaps we won't. But the attempt is its own kind of poetry, a reminder that curiosity can reach across not only oceans and planets, but epochs. So the question remains, lingering like a soft echo, would we even know? Maybe the Earth was truly silent before us, an unbroken wilderness of tectonics and tides. Or maybe it was not silent at all, but filled with fleeting choruses, civilizations that rose, sang their verse, and were erased, yet not erased completely. Their traces may still vibrate faintly, like the last shimmer of a bell after it is struck. We may never resolve it. That is the beauty and the ache of deep time. The Earth does not care to give us closure. It only turns its pages, writes new lines over old ones, and leaves us to puzzle at the margins. Our job is not to demand answers, but to keep listening, to keep asking, to lean close to the silence and wonder what it might be hiding. In that sense, the question that remains is not only about past civilizations, it is also about us, about how we choose to listen, how we choose to imagine, how we choose to mark our own brief chapter in the geology of time.